Welcome everybody to the second hack night here with me, Vasa, co-researcher at Ethereum OS. Today we will talk about our fresh release, which is the Ethereum OS ecosystem developed on and deployed on Optimism second layer. And we are here to talk about Colonies, which is our personal way to let the Ethereum OS ecosystem communicate between layer one and layer two on Optimism, of course. And yeah, when I want to share with you the way how we approach it on the development of this for this release, both smart contracts and front end, of course. And yeah, how it started and what is the real approach. I want to ask you something. For example, what comes you in mind when I say the word kiss? Maybe a song. I was made for loving you, baby, but it's not what we're talking about today because we are talking about the KISS approach, the KISS acronym on the software engineering environment, which is which means keep it simple, stupid. The software must be the simplest as possible to let it be comprehensible and to be really used in a modular way for every kind of software and for every kind of project you will have in mind in the future. Of course, you cannot think about what you will do in the future, but you can write your software directly to be the most simple as possible, the simplest as possible, in order to reach every kind of new ecosystem the future will give to you. And this is the approach we used for Colonies. We tried to, we did the same thing that the Optimism team did with the Optimism itself, to be at least similar 100%, almost 100% with Ethereum. So the developers of smart contracts will not have any kind of problem in bring their smart contracts on the Optimism ecosystem and vice versa. Bring tokens, send messages, brings and transfer Ethereum between the layer. The experience for the user is always the same, but also for the developer, because the Optimism team organized all the job, all the work to be the simplest as possible for a developer to approach on it. And for example, there are some particular things in Optimism. You know, the rollbacks, the roll ups. Sorry, the roll ups. You can read some Ethereum from layer one to layer two and vice versa. In the second, every transaction you do in Optimism is roll up and deployed on the layer one. And how to do this? They just created a simple way, for example, to receive information between the two chains, and it just used smart contracts. For example, the only one of the most difficult trick in Optimism is simple as this. If you want to know the block number of the layer one while you're on layer two, you just query a smart contract, a pre-deployed smart contract, which gives you every time the correct block number. And this is just the simplest way to the two network to communicate using smart contracts. Even if the layers are different because they do different things, they are the similar base, which is the AVM. And of course, in fact, Optimism is AVM compatible. And this is one of the layer that that the people can use to read the block numbers on layer one from layer two. And we wanted to give to people the same experience with colonies that just brings the assets collected by the Ethereum Solidity ecosystem on layer two and bring them to layer one for the ecosystem of the layer one. And how to do this? Yeah, let's start with the with the explanation of a colony. What is a colony? Let me just check the code, which is this. What does a colony do? Something really simple. It just sends tokens to the other layer. So no matter if you are in layer one or layer two, you just add the call to say, okay, you have this bunch of tokens, okay, Ethereum also, just send it back to the other layer, to the other side of layer. No matter if layer one or layer two, you can use it in both. And uh, and it is how the colonies work, really. In the Ethereum SOAS ecosystem, we created the two sides of colonies, which is the, let me check, the layer one side, okay, that simply take all the tokens received from the colony by the colony on L2 and send it to the treasury splitter, the ecosystem of Ethereum SOAS. And what the person should do is just to call the send method, and the colony layer 2, which is this, does the same thing. It just have some tokens received from the factories, the farmings, the routines, or other smart contracts from the ecosystem Ethereum SOAS in layer 2, and prepare everything to bring them to layer 1 with just one interface in just same way. Now, take a look at the code. You will not see the send method I showed you at start, the one in the interface send tokens. This is because to have the simplest ecosystem and the simplest environment as possible, we just implemented the entire logic in just one point shared in the two sides, and this point is called abstract colony. Abstract colony is an abstract smart contract, as you know, and it will be used to do the dirty job for you, and just having some particular stuff from layer 1 and layer 2. Let's try to figure out. So the last link I sent to you. Line 29, there is the send tokens method with all the token addresses you want to bring from the other layer. So this contract is an abstract contract, so it's not, you cannot deploy it by yourself. You need a concrete contract to attach it to a concrete contract, and no matter what is the layer, because you can be in layer 1 or layer 2, it doesn't matter. You can just, for example, pass the reward receiver, because the transfer will give you some reward for doing the transaction, to execute the transaction, the execute reward. And the send tokens just wants to know what is the receiver of the tokens. So the method resolve receiver is an abstract method that can be, let me check, yeah, can be, it's a virtual method that can be overridden, so everybody can write their own. And for example, in the case of the layer 2, the result receiver is the colony on the layer 1. And let's figure out the rest of the code. It sets the regular the correct reward receiver, just do some business with the token address. So let's say I pass a list of token address before to send them to the offsite layer. It just controls if, for example, you have the balance to transfer or something like that, just so collect data and then do the real transfer. And the real transfer is pretty simple because it is another private method called send, which is here, that calculates the executor reward for all the tokens you are going to send, and then directly send. Just transfer the tokens to the second part. And this could be possible, for example, in the layer 1, because you have all the tokens from the layer 2 landed on the colony on layer 1. Just call send tokens, and it will send them to the treasury register of the Ethereum OS ecosystem. But this method changes in the layer 2 because you cannot directly send the tokens from the layer 2 to layer 1. You need to pass them to the bridge, to the optimism bridge that does the hard job for us. And for this reason, this send method is virtual, of course. And this means that the one on layer 2 that will do the job is on the colony layer 2 layer. So let's explore it. Is this, yes, the correct contract? I will send you back here. If you see the name of the contract, you will see that the name is Colony, which is also an abstract colony. So inherits all the code from the abstract colony. So everything works in the same way, but the send method is overridden. What this means that instead of doing a simple transfer, it just called the specific method transfer to L1. And for each token, for each ERC20 token address, what the colony does is just to call the original optimism L2 bridge and say that someone will withdraw those tokens on the layer 1. So the code is similar. You have some tokens in a colony. You just collect the data about balance, if you have to send it or not. Just collect the fees, the reward, sorry, for the executor, and then do the hard job. And the hard job is split into parts. There is the layer 1, which is there is the layer 2, which is the one we already discovered, and there is the layer 1. The layer 1, which is let me check. Yeah, here. No, this is the abstract colony. Sorry. This is the colony on L1. You will see that they have the same names because we want to keep it simple. Okay, so there is colony and colony. They are not two different names, but of course the package name is different because the colony on layer 1 is in contract colonies implementation. The colony on layer 2 is in environment optimism colony implementation. This is what we did just to keep the differences, only the differences, because the code of the abstract colony is the same for both sides. And this keeps the code really small because, for example, the abstract colony is the one, no, sorry, this is not normal, yes. Yeah. The abstract colony code is the one with a lot of lines of code. The colonies themselves have a tiny piece of code because they are really simple. For example, let's just see the L2 colony part. It is extremely simple. And the L1 is simple too. And what is the difference between the colonial 1 and L2 in the transfer? The colonial 2, we saw that it brings the tokens to the bridge of optimism that we let pass through their roll-up system. What the L1, once they are landed on the colonial 1 to what to do? Just call again the method send tokens, but this time on the layer 1, not in the layer 2 anymore. And this will send the tokens to the treasury splitter with a particular thing similar to the factory of factories. You're sending everything, okay? But if the token is a token to burn, in our case is OS, it will be burned. So every OS you pass to the factory of factories from the colony from L2 to L1 will be burned. Other token will be transferred. And this is a particular method for this particular colony on L2. And the abstract colony just know that it has to send tokens to someone doing something, but it doesn't know the implementation of the colonies layer 1 and layer 2 know what to do, and this is the case. Another difference is how the receiver is resolved, because in the layer to the receiver of the tokens through the optimism bridge, of course, is the layer 1 address. But in layer 1 is not an address, it's the treasury splitter that can change in time through root proposals, of course. And we want, of course, every time the most updated address. So what we do with the resolve receiver method called by the abstract colony, in the layer 2, it does nothing, just returns to you the address of the L1 colony. In layer 2, it just called the root organization and resolve the treasury splitter manager address in order to pass it. And this is the receiver of the tokens, except for the OS because they will be burned. And so what this means? This means that the layer 1, layer 2 colonies are there to stay, even if we can change for any kind of reason the treasury splitter. Okay. So even if the treasury splitter changes, you don't have to change the layer 1 colony code, because it is dynamically prepared to resolve it, to have always the latest, the most updated address where to send the tokens. And this is what the colonies work, because they must be. See, I know that this is they are a few line of codes because we want to keep them simple, and we want to bring all the ecosystem in the simplest way. Colonies are one of them, but we didn't develop the colonies for the optimism ecosystem of Ethereum. So as we already developed even the factory of factories, the items, the DAX, the farming factories, the routines factories, etc. And they need to be a little bit modified, because, of course, there were differences between the two ecosystems, but not technical. They are not technical, but logical. Because, for example, in the layer 1 ecosystem, the factory of factories collect tokens and send them to the treasury splitter. The layer 2 doesn't have to do this. It just send the tokens or burn the tokens, if any, to the layer 2 colony. So they must contain the piece of code that does this. So let's say this. So I go back in the code. Let me just check. I will show you in the chat too, of course. Okay, so the Ethereums, let's take a look to the factory of factories. Right now, I want to take a little piece of code, a specific piece of code, which is, let me check. Please. here. Okay, so the line is this one. So, for example, in the factories, okay, there are some fees that can be changed through a sub-DAO proposal on the Ethereum OS ecosystem or layer one. Okay, and they are the burn percentage fee for factories or the transfer percentages for the transfers in when claiming reward or add liquidity or remove liquidity, sorry, from the farming contracts. And they must be changed. They could be changed from the from the sub DAO, and of course the factory of factories also have their own percentages. For example, to know how much to burn or how much to transact to the treasury splitter in order to save fees for the factory creators. And this is not possible on the layer two because, of course, in layer two there is not already the root organization, but we just provided some fixed fees for the factory of factories or farming contracts and whatever. And we didn't rewrite the entire code. We just let the feed info method be virtual, which is the one who provides the fee amounts on the percentages amounts and etc. And in the part of no, let me check. The colonies part, there is the implementation. No, no, go here. Contracts, environment optimism, inference, factory as factory. Here, yeah, and the method for the layer two factory of factories is pretty simple because while the one on layer one dynamically brings the data from the organization based on sub-DAO votes, in the L2 part of the factory, they are hard cabled and they are fixed. But the rest of the code is the same. And look at the code of the factory of factories in layer two. It is just empty, if you see, because the entire code is on the layer one. And in fact, the factory of factories on layer two extends the original factory of factories for the layer one. So again, we just took the entire code of the layer one part to the layer two part in a simple way and just edit what we need to edit and nothing more. Same stuff for the factories um, for the farming or the routines. Let's take a look. And then, okay, a lot of tabs open here. So this is the farming factory on the layer two. It again extends the layer one Ethereum's factory, which is the abstract factory for all hours factory, and it just changed the way the farming contract is deployed, and nothing more, because it just need to have a little piece of code for the new system of deploy, just particular for that, and that's it, nothing more. The entire code is on the Ethereum's factory side, which is an abstract contract on layer one. Same stuff for the routines, which is the code is called fixed inflation, but it is the routine. Same thing. The code is really, there are really few lines, and the only thing that changes is the deploy method that just deploys the factory on layer two. But the entire logic is again in the Ethereum's factory. And yeah, this is what we wrote on Colonies. And all the other stuff is 100% identical to the layer one uh, part. For example, the items, the DAX, and any other part. What we just modified is something on the DAX code because if, as you know, the DAX on layer, the DAX just have reservation. So you can reserve an NFT in order to unwrap it only if you want or after a little bit of time. Okay, and this logic is based on the block number. For example, you have, I don't remember what is the correct amount of blocks for the reservation, but after that block, you can everybody can release the reserved NFT, and all this stuff works because of block numbers. Uh, but of course, as I showed at the very start of this presentation, the only different thing in optimism layer and Ethereum layer is the way that the blocks are used. Because in optimism you have one transaction, one block. Every time you do a transaction, you have a new block. Of course, this is not the same thing for layer one, and so the time cannot. So you cannot use L2 blocks to scan the time. You have to use L1 blocks, and this is the only difference. As I show you at the very start of these, let me just check again. This link here, the optimism link, we already showed. Let me show the video. The way to have the block number on layer two, you can also you can continue to use block.number primitive call on Solidity or layer two, but it will give you the block number on layer two. If you want L1 block number on layer two, you have to use the IOVM L1 block number smart contract, which having these the address you will see, which is kind of weird, but it is because it is a pre-deployed smart contract on the Genesis block on layer two, and every time you call this smart contract, and Optimism L2 node does the business for you, so it brings the current L1 node on L1 and brings it to L2 for you. And this is the only difference, for example, in the DAC, the DAC for Optimism and DAC for L1. And let's take a closer look on it. So we just edited a little bit the code of the DACs in order to introduce that block number stuff. I'm just going to retrieve the code. Just give me a second, please. Projection. Even here you have contracts projection. I'm sorry, I am wrong. Yeah, the projection and the environment optimism projection, that which contains the part of the DAC for the L2. So let's explore the code of the 721 DAC wrapper on L1. Okay, as you can see in the line I am showing you here, in order to manage the reservations, it used to call the block number method that in layer 1 will gives you the block number from the L1 code. If you go in the specular contract, which is the 71 deck, but in the optimism environment, you will see that this contract really has no code because the only thing that change is the way to take the block number in order to manage the reservations. In the L1 part, you just take the solidity one. In the layer 2 part, the method is the same, is underscore block number for both, but in layer 2, it just called our Swiss knife optimism library, which calls the L2 smart contracts that provides the block number for the smart contracts. And the code again is just a little bunch of lines because everything works in this demonstrates that everything works in the same way. So we didn't need we just, for example, in our front end we just considered the optimism chain as another test net, let's say, chain, because in our front end you can use mainnet and Rigby testnet, okay, because we can switch, but the system is made to in order to accept other chains, Kovan, Optimism, or any other. So it was extremely simple for us to introduce also in the front end the Optimism and let them communicate between, for example, for showing metadata of the original L1 items or NFTs, also in layer 2 and vice versa. Um, that's it, because the code is extremely simple and the logic were already done on layer 2. They already worked, we already tested it. We just brought down deploying redeploying again the correct smart contracts because we need just to modify the sources, because for something like DEX or factories we need the optimism contract and nothing more. That's it. um, I don't know, guys, if you have any question about it, because yeah, the code was so simple that everything is here. Bachi is writing to us. How much cheaper was to redeploy ONOP compared to L1? Extremely cheaper. If you remember when we deployed the L1 ecosystem, we were top gas spender for a couple of hours, as I remember. But in the in optimism, the it's you cannot compare the expenses because it is extremely cheaper in a layer 2, and also the all the transaction procedure lasts not so much time. Let's say also that in L1 we also deployed the root organizations, sub DLs, those factories, all the models, etc. and it took more time than this. But yeah, the expenses were, I don't remember the correct expenses, but I think that it is 90% less than what we expected to spend. Yeah, the mainnet deploy was was really a good medal for us. But yeah, for another project, Matteo Icari said, for another project, is it difficult to recreate the same structure? Absolutely not, because if you're talking about the colony, it is absolutely not, because you can start from the abstract colony. In the L2 colony, you don't have to edit nothing. In L2, L1 colony, also not, because you just provide the address of your organization, and all the logic does the business for you. So everything is totally it is completely configurable. Can we use L2 in votings? Yeah, once the organization will be there, if there, yes, why not? Another question by Jack. No, discouraged. Let's see if I can share you something particular with you. But yeah, it was so simple that there is no nothing to say. Hope guys you're enjoying the new front end and to pass from L1 to L2 sites. Hacker mode, Matteo. Matteo loves the hacker mode. My favorite graphic mode, UI mode. You know that you can change the UI on the QSOS website is the sepia one, because I love those colors. I love those colors. Definitely love those colors. So yeah, in order to introduce the optimism verticalization uh, from for the layer two, we need, of course, we needed to edit some previously deployed smart contract. So they are not 100. So for example, the factory of factory on layer, the actual version, not the deployed one, just works, is okay, and etc. But the L2 ready factory of factories is a little bit different because of those differences, which are not based on the behavior of the logics inside, but just in order to extend them to provide verticalization for other layers. But no any change on the logics, just on the structure of the smart contract. So it is an upgraded version. Same for the DEX, for example, the 721 deck wrapper, the already deployed, just brings the block number, calling block dot number solidity primitive call. In the case of this new version, the block number retrieval is abstracted, because there is the layer one behavior, there is layer two behavior, but the deck now doesn't know the block number call anymore. Let's say, just call the abstract one, give me the block number, no matter if what is the source of the block number, if the solidity call itself or the L2 smart contract itself. The code is the same. It just knows that calling underscore block number gives back a block number, no matter if provides it. Uh, in the layer 2 there is a provider, in layer 1 there is another provider. So the code, the behavior, the logic are always the same. Same for the factory of factories, for the farming factories, decks, etc. Just a little bit changing the structure, nothing more. But the change were really, really, really simple. I don't know what to show you more. Let's take a close look on the abstract colony, which is the most important and most interesting contract in the entire work. So let's start to describe. Yeah, every of course, if you pass WETH token, okay, they will be considered as Ethereum. So, for example, the first mapping on this contract here, line 20, I mean, says to you if the address is WETH or not. So, the deployment method used for both L1 and L2 is the same. It just what it is not the same are the parameters used to deploy the contract, because the wet address on layer 1 has an address. The wet address on layer 2 is different, of course, or the receive resolver could be different, and it is different because in layer 2 there is the L1 colony address. In layer 1 there is the root organization address. So in an order, we first deployed the L1, and using that address we deployed the L2. And in this case, the receive resolver is different too. The executor reward percentage, I don't remember, but I think that it is similar to both sides, and nothing more. The method just implements the receive solidity method because it must receive Ethereum. Of course, if you don't have the receive method in a smart contract, you cannot receive Ethereum. Are you hear me, guys? Can you hear me? Is there any problem? Yeah, Jack can hear me. So maybe Matteo, do you have some problem? Okay. Okay. Thanks. So what I was saying is that, so let's try to figure out. Okay, I am on layer 2. Someone used the farming contract or something like that, and some tokens arrive on layer 2. So a user, an executor, calls the send tokens method on layer 2. What will happen? First of all, the executor must pass the list of the token addresses to pass from the other side, because yeah, the tokens knows there are it has some tokens, but it doesn't know how many and what tokens. So the executor must pass them from the external. Um, L1 gas array is a parameter used for the optimism transfer from layer 2 to layer 1. Reward receiver is the address that will receive the reward for the execution of the call. If it is not well specified, so it is address 0, the reward receiver is the sender, so who is sending the transaction itself. So first of all, it is calculated. So the token addresses must be non-empty list. So if the list is empty, the call stops here. If if there is something in the token addresses array, it continues. And first of all, the to address is defined. The to address is who will receive the token you are sending from the colony to the other side. So I repeat, the case of L2 is colony L1. In case of colony L1 is the latest version of the treasury splitter address, and it is resolved. So the resolve receiver method is a public but virtual method that just simply returns you the receiver the receiver that you passed from the construction. So keep in mind we already know two. So this is the method resolve receiver, which returns you the L2 the L1 colony address. Sorry. This is in case of the colony in layer 2. In colony layer 1, let me check it. Couple of minutes, guys, because it's hard to close all these contracts. Okay, let's take it back again. Right. Here, we have to go in the Ethereum, so at computational orgs, contracts, the exposed method, colonies, yep, the implementation, and colony here, which is, I already passed you, but I can pass you again, which is this. And you have at line 23 another version and implementation and customization of the resolve receiver methods. Because in L1, what we pass at construction as a receiver resolver is the root organization itself. From the root organization, we go to the sub-DAO manager and the treasury splitter. So this is what it is used for the organization, and it is always updated. And it is the receiver that will receive the tokens. So let's go back to abstract colony. So we resolved the receiver, which is all the hard cable smart contract of the treasury splitter one. Let's have the real reward receiver, which can be the reward receiver passed by input if it is not 0, or the MSG sender if it is 0. Let's take a boolean, send Ethereum. If it is true, we also send Ethereum, not only tokens, and start to analyze the what is inside the token addresses method. The token addresses array. Sorry. So take the token address, verify it is his wet address, because if it is wet address, we unwrap the wets and send Ethereums to the other side. So there is the try unwrap wet method that works both for L2, L1 and L2. It takes the balance of the wet address, and if it is greater than 0, it just withdraw them. If this happen, the send Ethereum method, the send Ethereum boolean is true, and it is true. Then the token addresses. So if the send a method, so if the token is address 0, which for us means Ethereum or with wet, we don't already send the tokens, because this is because in the token address array there can be also token zero, which means Ethereum, also WETH, which means also Ethereum. So to say gas, the transfer is just one. We just know that we must send some Ethereum. So we will save the sendf boolean in order to use it in the future. And in fact, to send Ethereum, we just take the entire balance. So keep in mind, I have in my contract one Ethereum and one WETH. After unwrapping the WETH, I have two Ethereum, but just I know this just at the end of the cycle. So when the cycle is complete, I take the balance of the contract in Ethereum this time and send it to the other side. So, in any other case, if it's not Ethereum or WETH, the send method is called as is. So let's see. Send method. Send method does something really simple. Just transfer the tokens or the ethereums for the reward receiver. So it first transfer the reward to the receiver, and then the rest of the amount. And to do this, there is a particular method called underscore send again that calculate the execution reward basing on the value. So you have the execution reward, and you do this calculation, this one, in order to do not lose position in calculus, and just to split the amount for the execution reward for the other part of the layer, and send them to the correct receiver. And that's it. And this is the base implementation of the send method, which is virtual. In the colony on layer 1, sorry, this is layer 1, yes, of course. The send method is a little bit different because it sends the executor reward to the receiver, but it also burns the token if Ethereum's is the token is Ethereum's. So if the token is Ethereum's as and the amount is greater than zero, it is burned. So if you write your own colony, you can also specify a token to burn, because in fact the name is general for general purpose use. Else the token is transferred normally, like in the other side. In fact, this colony has another initialization method, which is token to bird address, that specify, if any, the token to bird. Okay. While in the L2 part of the code, let's pick up it. Environment optimism. Colonies, colony on the layer 2. The behavior of the send method is again a little bit the same. Let's say that it sends the amount to the receiver, and then transfer to L1 the rest of the amount. And transfer to L1 just means call the L2 ERC20 bridge in order to start the withdraw procedure. In optimism, when you are bring something from L1 to L2 is called deposit. When you have to bring back something from L2 to L1 is called withdraw. So there are the two methods. So in L1 bridge, there is deposit 2. In L2 bridge, there is deposit withdraw 2. Sorry, I am also sending you the link of what I'm talking about here. That's it. Of course, this procedure, because of it uses the standard optimism bridge, you can withdraw the send token after a week, and you have to do the normal transaction on layer 1, and once it is finished, the token are landed on the L2, L1 colony, sorry, L1 colony. From that, you can call send tokens from the L1 side this time to bring the tokens to the treasury slipper. And yeah, we tried to have an automatic behavior for this, but I I don't know, we didn't we didn't have the possibility to do it automatically, so you have to do it manually as any other kind of withdrawal on Optimism. Okay, guys. I think that now it is really everything. Thank you very much for listening to me, and I say goodbye to you for the next time. Thank you all. Bye bye.